Okay, hello. So I hope everything is all right with you. So what we did the other day, I just give you a summary of the topics on section 1.1. So we talk about the linear algebra and we find out that we are going to investigate the solution to the system of the equations. So we just review the linear system from the past and we find out that these type of systems may have a one solution, no solution, or infinitely many solutions. So if we get a system with more variables and more equations, so what we're going to do, we are going to summarize our operations. We summarize the operation using a matrix, okay? A matrix that we call it augmented matrix. So that matrix would be the one that will put the coefficients and the constant terms of the system together. So I'm going to continue, we need one more example, and then we are going to get to the section 1.1.2. Okay, so let me just go to my notebook and continue. Any question on these type of ideas, you can come to my office hour, the one that I posted, okay, in the evening of the Monday, Wednesday, or Tuesday, Thursday between 11 and 12. Okay, you are welcome to come. No appointment is needed, but if you send me an email in case, I'll be on Zoom. But it would be nice if you send me an email to remind me that you are coming. If it's not working for you, you want any other times, just email me and then we can arrange it. So this is what we did, and it's going to be completed at the end of the week. I'll also post these lecture notes for you. Okay, so that is the way we discuss the augmented matrix. Okay, so basically what we do, if the system of the equation is given, so we are going to drop the variables if you like. We drop the variables, we are going to have, these are going to be these columns and rows, if you like, corresponds to the coefficients, and the last one is going to be just the constant term. So we just checking that we be able to to get the augmented matrix of the given system, or if the augmented matrix is given to you, are going to translate it into the system of the equations. Okay, so that would be interesting to know. But sometimes if this matrix would be an easy one, or if we can do some operations that makes this, if you like, you get lots of zeros for the entries, then we'll be able to get to the solutions more quickly. So, for example, if we have the following augmented matrix, so you have some problems in your book related to this problem. So I give you one example so that you know what's going on, and that would be, that can be used later. So sometimes they ask you to solve the system, but they just give you the augmented matrix. So we want to find, okay, that's it. We want you to find all solutions, find all solutions. We want to find all solutions of the linear system with the given matrix of the linear system with the given augmented matrix. Okay, that's it. Augmented matrix. There are going to be three different cases. Okay, so to take one from each. The first one, this is going to be the given matrix. So this is it. We have a -5. We have a -5 and -1 and 3 and 3. That's the first row. The second row is going to be 0, 3, 0, 3, 5, 5, and 8. Okay, and this one is going to be 0, 0, 2, and negative 4. So this is going to be a matrix that we're going to have. It's going to be very a special matrix that we're going to talk about it in a minute. As you can see, each row starts with a, we have a non-zero number -5 over here. Then if you go a little bit to the right, then you get the other non-zero numbers. And again to the right, we get a 2 here. So it's going to be in a special format that we are going to introduce it right away. Okay, so as we go down, the number of the zeros, increase with the zeros would be more and more and more. But we'll get to it. But eventually, suppose this is given to you, you want to solve the corresponding system of the equations. As we talk about it, the last row would be considered as the last column would be considered as a constant. So if you like, you can separate it. You don't have to. So the other ones would relate it to the variables, the unknowns. So I'm going to call this one x1, x2, and x3, or just xyz, and this is going to be the constant. So then I realize that there are 3 unknowns that I have to take care of it. So if you read from these, so the corresponding system is going to be, you see, so the solution is going to be, this is it, your system would be translated into this format. So the first part is going to be -5x1. You see -5x1 minus x2 plus x3 equal to 3. And the second one, there is no, okay, x1, 0 times x1 would disappear. So that gives you just 3x2. Okay, 3x2 plus 5x3, which is equal to the 8. And the last one, there is no x1 and the x2. So quickly that gives you 2x3 equal to the -4. That's what I was talking about. If this non-zero would be farther to the right, this always is going to be the result. So from the last part, quickly, we can find the x3. So this is it. So that gives x3 equal to the, okay, x3 is equal to the negative and -2 right away. Okay, this is going to be a -2. So what we can do is we can put this -2 into this equation. Okay, we have a -2. So we go from this part. We go from this part that would give us a 3x2 plus 5 times x3, which is going to be, okay, this is it, 5 times a -2 equal to the 8. So we can solve for the x2. So that would be -10. That's going to be 18. 18 divided by 3, that gives us 6. So x2 would be equal to the 6 from the second one. Okay, so if you put all of them into the first one, if you're just using everything on the first one, so that give a 5, -5x1 is just the missing one. So the x2 is a negative, that gives you a -6, and the x3 -2 equal to 3. So that give you, okay, this is going to be -8, and we move it to the other side. So that gives us 11, and then we can find the, I just double check to make sure I get it all right. Okay, so far I got the x3 equal to the -2. Okay, so when I substitute, oh, I'm sorry, I missed this one. It's a -5x1 minus x2. There is a negative sign here, so to make it to the positive. Now that would be fine. Okay, so this is going to be a, what is missing is, so we have the x3, which is a -2. Okay, because this is not going to be the same that I have. I have the x3 equal to, okay, x3 is equal to the -2, and the x2 is equal to the 6. And when we, oh, there is a 3 here that I missed it, sorry. That's a 3x3. Okay, so that's going to be 3x3, which make this one into the -6. So that's going to be a -6, and this is a -6. So it's going to be 15. So the x1 would be equal to, okay, that's it. So the x1 would be equal to -3 again. Okay. So basically the solution of the system x1, x2, and x3 is going to be, we get the -3, 6, and -2. So this is going to be the solution to the system. Okay, so if this is going to be in this format, that as we go on, we move the non-zero number to the right, so the system can be solved easily. So that's going to be the case one, and we are going to see in a minute that how we're going to change it into this format. Okay, this is going to be the case one. So what is going to be the case two? Okay, so the case two is, suppose this is going to be the resulted augmented matrix. So that's going to be 1, we have a -3, -3, 5, and a +3. Then the next one is going to be 0, okay, 0, 1, 2, and 2. And over here we get the 0, 0, 0, and the -1. Okay, this is going to be the case. Again, this is the same format that I talk about it. The non-zero number, you start with the non-zero. When we get to the second row, you see the non-zero is to the right of the first one. Okay, that's it. And if you go down, you see the non-zero is further to the right again. But there is something interesting about this one. Again, if you change it to the system, so you realize that you are going to have 3 unknown, x1, 2, and 3. But you look at this last row here. You see this one? x1 is 0, x2 is 0, x3 is 0. Okay, so that gives you 0 equal to the -1, which is impossible. Okay, so as soon as we get to this part, we realize that this corresponds to the 0x1 plus 0x2 plus 0x3 equal to the -1. So this means 0 equal to the -1, which is impossible. So the system is inconsistent and there is no solution. Okay, there is no solution. There is going to be no solution. Okay, you know that the system, just for your information, the system is going to be inconsistent. Okay, it's going to be inconsistent system. So sometimes we may, we get the augmented matrix, and we simplify it, and eventually we arrive at this type of format. So uh, when we get this type of format, we realize that this is, so in this case, we get one solution. Over here, we get, okay, no solution. Okay, so that's going to be the case two, as we talked about it before, the possibilities. Now, sometimes we may get this one. So again, a system is given to you. We have the augmented matrix, and we did the simplification, everything. We arrive at this matrix. So the matrix is going to be 1. It's a -3. Okay, -3, 0, 5, 0, and 4. That's the first row. The second one is going to be 0, 0, 0, 0, 1, 2, 0, and the -7. And the third row is going to be 0, 0, 0, okay, 0, and the 1, 1. And the last one is going to be 0, 0, 0, 0, 0, 0. You see? Again, it's the same format that I talk about it. And this is your non-zero number 1. When we get to the next one, you see the non-zero number is to the right of the previous one, and you just move forward to get to the one here. Okay, and the last spot all is 0, 0, 0, 0, 0. So that would be a very popular case. So we check to see how many variables are going to have. Okay, so this is going to be the column of the constant. So how many unknowns are you going to have? We have the x1, x2, x3, x4, okay, and x5. So we have 5 unknown. Okay, you have 5 unknown, and as you can see, you have only 4 equation, 1, 2, 3, 4. So what we are going to do is, you see this last part? This last part means 0 equal to the 0. 0 equal to the 0, but this one was 0 equal to negative 1. So 0 equal to the 0 is always, true. So if this is going to be the case, that is the indication that this system would have infinitely many solutions. Okay, and since the number of the equations are going to be less than the number of the variables that we're going to have, in this case, you see, when we have infinitely many solutions, this is where you have the option of some of these variables would be, would be free if you like. It can be any number you like. Then you have to identify it. So from the last column, we won't get anything. It's going to be 0 equal to the 0. From this column, we get x5 is equal to 1. Then you can work on this. So if we translate it, okay, so the solution, let's see it translate to the system of the equation. So the first one is going to be x1 minus 3x2. There is no x3 here, so plus 5x4, and there is no x5 here, equal to the 4. So that would be the result of the first one. Over here, no x1, no x2, so we get the x3. It's a 1x3 plus a 2x4. Okay, and there is no x5, so that gives you a negative 7. Negative 7 here, you see, no x1, no x2, x3, x4, so we get x5. That gives you x5 equal to the 1, which is going to be one of your solution. And for the last part, you won't get anything. 0 equal to the 0 if you like. So we know that this system would have infinitely many solutions. Okay, so the system would have infinitely many solutions, that then you have to identify those solutions for us. Okay, so as you can see now, we have 3 equations only. So these 3 equations will give us 3 solutions, but we need 5 solutions. You see, 1, 2, 3, 4, 5. So since the system is dependent system, so this means you are going to have 3 free variables, if you like. Okay, 3 free variables. You can call it anything you like. Okay, you have to pick all those. You see 1, 2, 3, 4, 5. Okay, 1, 2, 3. We have 2 free variables. So you have to pick those 2 free variables, whatever you like, to be able to find the other one. So what we are going to do is, we have already the x5. You see the x5 is already given to you. So the x5 is equal to 1. If you want to find the x4, you have the x3 and the x4. So you have to pick one of them to be free. So I'm going to pick the x4 to be free. Okay, I'm going to call it S. Okay, S, any number. S is a number. Okay, it's a free number, can be any number. Okay, so I'm going to have 2 solutions now. Now I have the x4. I can use this one to get the x3. So now x3, okay, x3 plus 2s. 2s is equal to the negative 7. So I can find the x3. So my x3 would be negative 7 minus 2s, when s is any number. Okay, so I have the x5, 4, and the 3. So I go to this one. Okay, in this equation, I've already got the x to the 4th. Okay, I don't have the x2 and I don't have the x1. Remember, I can pick 2 free variables. I've already got the x to the x4. So I have to pick one of them, x1 or x2 free. So what I'm going to do is, I'm going to pick the x2 to be, okay, let's x2 to be a free agent. We call it t, when t is any number. Is any number, any real number. Okay, so there you are. I have the x2, then I put everything here to get my x1. So what's going to be my x1? So the x1 is going to be x1 is equal to what? It's equal to the 4 plus 3x2 minus 5x4. Now, if you substitute, okay, if you substitute, what you have? Okay, this is a 4. This is 4 plus 3x2. x2 is t, 3t. 3t minus 4x4 minus 5s. So in this case, this is going to be the solution of the system. This type of interpretation is going to be very important for us, very important to be able. It's not enough to say that this system would have infinity many solution. Okay, the system has infinity many solution, but where are going to be those solutions? So the solution of this equation, this system, is going to be okay, it's going to be we have x1, x2, x3, x5 with this format that we put over here. So I write it down here for you. You see the system, its solution is going to be x1, x2, x3, x4, x5, which is equal to x1. This is the x1. x1 is 4 plus 3t. Okay, 3t minus 5s. x2 is t. Okay, x3. x3 is a kind of negative 7 minus 2s. Okay, that's x3. x4 is s, and x5 is equal to the 1 for any number, okay, any number s and, okay, s and t, if you like. You see, this is the way you are going to identify the solution of the system. But this is what going to be, this last example is going to be such an important one when we go on. So that's why I wanted to see an example right away. Okay, just get used to them. Okay, so when we get to 0, 0, this system without the infinity many solution. When we get infinity many solution, you have to write the solution. We call it in parametric form, if you like. You have to give us a tool, a formula, so that we be able to find it. So as you can see, this last row won't give you anything. When you write the equation, you have only 3 equations, 1, 2, 3. So these 3 equations give you 3 solutions, but you have 5 solutions. So this means 2 variables. Okay, 2 variables are going to be free. Free means we just pick it, to be a parameter. So I start from here. You can pick anything you like, but I pick the x4 because that would enable me to find the x3. So I keep the x4 to be equal to the s. Then I be able, x5 is 1, x4 is s. I will be able to find the x3. Then I want to find this one, then I have to pick another one. So I pick the x2 to be equal to the t. So then you substitute to get your final answer. Okay, so these are 3 possibilities that you are going to do it over and over and over during this chapter. Okay, so get to know them. I'll just give you one so that we'll be able to quickly to get the idea. Then we are going to repeat it again and again. Okay, so now we are done with 1.1. So this is all you have to know about the 1.1. You can read your book as well, but these are going to be the the summary, the things that we're going to use. Now, what's going to be the next step? The next step is these 3 matrices that I give you. You see, these are nice. These all have that property that I talk about it. You see, look at that. As we talk about it, you see, if you have a row which got all zeros, this would be right at the end. 0, 0, 0, 0, 0, 0, 0. Now, what's going to be the idea of the other one? The idea of the other one is, if a row starts with a non-zero number, this is the non-zero number. Okay, so non-zero number, non-zero number, non-zero number, because this would contain all zeros. So for the rest, there must be an order. The order is as you go down, as you go down, this non-zero number must be shifted to the right. So if you compare these two together, the non-zero in the bottom one is far to the, okay, to the right of the other one, or this is to the left, you see. That's it as we go on. If a matrix would be in this format, we have a special name for it. We say, oh, this matrix is in echelon form. So echelon form means this is it. If there is going to be a row containing all zeros, that would be right at the end or the bottom. For the other one that would have a non-zero number, those are going to be such that as we move down, okay, the non-zero entry would be shifted to the right, or the previous one must be to the left. It doesn't matter. You can start with each of these. This leading number, it must be a non-zero number, but in your book they ask it to be, ask it to be 1. We can change it to the 1 easily. We can divide, we can change it to the 1. But even if it's not going to be 1, that's fine. So we are going to introduce this format. It's very important. So this is going to be called echelon form. There is another one that if you have echelon form, this 1, 1, 1. But one more condition. The condition is anything above these ones, above and below must be 0. See, 0, 0, 0. This one, 0, 0, 0. This one, 0, 0. If this is going to be this would have this extra condition, so, oh, this is reduce echelon form. Okay, so we have a row reduce. Okay, we get row echelon form and row reduce echelon form. We like both of them to be able to use the system, to solve the system of the equation. And this is going to be your job. When these matrices are going to be in echelon form, it's easier to handle. Okay, so this is going to be the topic of section 1.2. So let's get to know them. So I'll just give you this example. That would be a motivation. And now we are ready to do it. Okay. You see this one? It's start with a non-zero. The non-zero shifted to the right only. So this is just reduce echelon form. This is just echelon form. In your book, they ask these numbers to be 1, but it's okay if it's not going to be 1. But this is not reduce echelon form, because above and the below of this leading non-zero, you get a non-zero number again. But let's define it to see what's going to be job. Okay, so there's a reason for it. The reason is that okay, when you get to those format, it's easier to solve the system of the equation, and that is going to be our target. Okay, so let's get the definition first. A different way to define it. So I'm going to summarize it in one format rather than 2 cases. Okay, so let's go to this is in fact discussed in section 1.2, very important section. Okay, this is it. 1, 2. So first thing, we are going to talk about the row echelon form. Row, that's it, row echelon. This is the expression that we're going to use quite a lot, echelon. Okay, this is it. Just make sure you get it right. Echelon form. Row echelon form, in short, we are going to refer to it as a row echelon form. So I use this expression from time to time. So what does it mean? This is the one that I talk about. Let me write it down. Then we can discuss it. This is it. A matrix. In this case, it's going to be just augmented matrix for the time being. A matrix is in row, okay, echelon So it's going to be in, this is, let's say, E echelon. Okay, that's it. A matrix is in row echelon form. Echelon form if it satisfies the following. If it's, okay, it satisfies the following condition. The following, okay, conditions. Okay, what's the condition? The first one, as we talk about it, okay, any row consisting, or the rows, any row consisting entirely, okay, entirely of zeros, all zeros, 0, 0, 0. All zeros occur, okay, occur at the, okay, at the bottom. Okay, occur at the bottom of the matrix, of the matrix. That's it. So I missed the rows. Any rows. Okay, any rows consisting entirely of zeros occur at the bottom of the, it must be right at the end. So if the row got 0, 0, 0, 0, 0, that would be at the bottom of the matrix. That's the first one. Okay, what is going to be the second one? Those non-zero numbers that I talk about it. So for each row, that does not consist entirely of zeros, okay, if there is a non-zero number, that's what I mean. And the first non-zero number, the first non-zero number, okay, non-zero number on entry is going to be 1. It can be any number, but I go with the definition of your book. It can be any number, but 1 is better. So I go with your book because, we have to check your assignment, everything. So it is 1. This 1 is going to be called, call it the leading one. Calling a leading one because it's going to be used for some other purposes in future. Okay, we call it the leading one or a, okay, pivot. So get to know this expression, okay, pivot. So we say, oh, leading one or pivots. Okay, so that's going to be the 1. So if you get 0, 0, 0 at the bottom, if you get the 1 which got a non-zero number, that non-zero number must start with the 1 or any other numbers. Now the order, when you go from one row to the other row, this leading one should be shifted to the right. So that's the third condition. The third condition for 2 successive, for 2 successive non-zero rows, non-zero rows, the leading one or the pivot in the higher one. In the higher row is going to be, they talk about the higher, is going to be farther to the left. I talk about the lower one, which was further to the right. It doesn't matter. Okay, to the left. Okay, So this is it for two consecutive non-zero rows. The pivot in the higher row is further to the left than the pivot, or just leading one in the lower row, in the lower row. Okay. So the top one, the leading one is to the left, or the bottom one, the leading one is to the right. Okay, so that's going to be the order that we're going to have. Okay, so this is going to be the row echelon form. Now, if it's already in the echelon form or row echelon form, and everything above and below those ones are all zeros, then it's going to be called row reduced echelon form. Okay, so let's finish that one too. A matrix in a row echelon form already. Okay, row echelon form is going to be called, okay, is in this new one, is in reduced, okay, reduced row echelon form. So it's going to be reduced row echelon form, an extra condition. Okay, and this is going to be the case. So it's going to be in row reduced echelon form, where every column, okay, every column that has those leading term, that has a leading one has zeros everywhere else, zeros in every position, above and below. Okay, above and below its leading, okay, leading one. You see, that's going to be the case. So basically, this is, a kind of format that you're going to have. You see, this is going to be your leading one, and everything else, if you like, it's zero. Then you got here, okay, for example, this is it, and then you get here, this is it. So everything below and the above, these leading terms are going to be all zeros. In this case, this is going to be called a row echelon, a reduced echelon form. Okay, the reduced echelon form is, is the best case, but most of the time we be fine with this one. Okay, so the leading uh, non-zero numbers, if you like, it must be one. I talk about it in the case of the echelon form. Even you can go with a non-zero number, I don't mind, but we go with your notion of your book. So in your book, they ask you to get, they wanted to be one to get these numbers. So let's have an example to make sure we have nothing to worry about it. You have some problems, okay, a couple of assignments. They list matrices and they ask you whether they are in row echelon form or not. Okay, this is it. So that would be our definition. So let's have an example to get these numbers. Okay, so let's example. Our first example is going to be basically we want to determine whether which one is it. Determine, okay, determine which of the which of the following matrices, okay, which of the following matrices are going to be are in row reduce, okay, sorry, row echelon form. Let me write it down. In row echelon form, row echelon form. Okay, let's check these, a couple of them. Okay, just the row echelon form. So this means you just consider the position of the leading ones and make sure that the order is that they would be moving or shifting to the right. Okay, let's check. The first one is, this is it. We have 1, 3, 2. Then we get a 0, 0, 0. Okay, we get the 0, 0, 0. And this is going to be 0, 0, 1. This is it. Okay, so this is it. Let's see what's wrong with this one. So as we talk about it, you see the non-zero element is 1, but if you have a row containing all 0, 0, 0, this cannot be in the middle. It must be down here. Okay, so in this case, we may call it A so that we refer to it. Okay, so the matrix A, if you like, solution, the answer is no. Okay, it's not. So the second row, if you like, so the second row, okay, the second row is not below the third one, below the third one. Okay, the third row. You know that you have all 0, 0, 0, so this must be right at the down the bottom. So the answer would be no, or this one. Okay. I mean, if you switch it, then it would be fine. If you switch it, we get 0, 0, 1, and we get the 0, 0, 0. So this is not going to be the case. So the second one, this is it. We get something like a 0, -1, 2. Okay, and the next one is going to be 0, 0, 1. Then you have the 0, 0, 0, and the 0, 0, 0. You see, that's a nice one. The non-zero number is the -1 here. Okay, it's okay to be -1. I just get change it to the positive one just to go on with your book. Otherwise, it's fine, really. Okay, so this is it. We get the non-zero number here. So the next one, the non-zero number is further to the right, and everything else is 0. So this is correct. Okay, so the solution is going to be yes. The entries with 0, 0, 0 on the bottom, and for the other one, the order is satisfied. Okay, getting another one, part C. Okay, and the part C is this one, which is fine, 1, 3, 2, 5. Okay, and this is going to be 0, 0, 1, 3. And then you have the 0, 0, 0, 1, and the 0, 0, 0. So, everything is fine for this one. Because this is it, the non-zero is 1. The second one, the non-zero numbers shifted to the right and shifted to the right. And the last row, you get the 0, 0, 0 over here. Okay, so nothing to worry about. And we get another one. Okay, so the other one is going to be, we have the 240, 240,132, and then we have the 000. See what's wrong with this one? The bottom rows we have 000, but you see the first one, we have two non-zeros here. Because if you take the first one to be true is a non-zero number, you must get 0 here. So it is not going to be the 1 because the first non-zero number in the second row, that the order is not the one that it should be to the, okay, it would be shifted to the right. So this is going to be the case for the row echelon form. Okay, so check the one for the reduced row echelon form. So we have another example. So determine if the matrix is in reduce, okay, reduce echelon form. Okay, it's a reduced row echelon form, if you like, this is it, a reduce row echelon form. We talk about it, the extra gene is above the, okay, above and below those leading one, you must have 0 only. So checking the first one, this is it, A is equal to, we have 1, -3, 1, -3, 5. Okay, and we get the 0, 1, and 2. And this is going to be the 0, 0, 0. Check to see if it's a reduced echelon form. Okay, the one with the zeros is here. Okay, and that's it. So this is already in echelon form. Okay, so it is a row echelon form because of this leading term. But you see this is the leading one. You get the leading one, below and above it, you must have zeros. So this means this is not going to be reduced echelon form, okay? Because everything else must be 0. So the answer is going to be for this one solution. A is in row echelon form, but not row reduce echelon form. Okay, why? Because this number must be 0. Anything below and above it must be 0. Okay, so this is not going to be row echelon form. Okay, so give you another one. To see what's going to be the next one, I write it down here. Okay, so we have everything in one place. So the next one is this matrix. B is equal to, okay, B is equal to the 1, -3, 1, -3, 0, 5, and 0. And the other one is going to be 0, 0, 1, 2, 0. And over here we have a 0, 0, 0, 0, 1, and the 0, 0, 0, 0, 0. You see this one? This is it. You see the leading term is 1. Leading term is 1, 1. Fine. So we check, this is the leading one, everything else is 0 in this column. This is the leading one, everything else above and below is 0, it's fine. This is the leading one, everything above and below it is 0. So B is, okay, this is it. B is in row, reduce row echelon form. Okay, so the difference is going to be the one that when it's going to be reduced echelon form, everything else, in each column containing the leading term, the leading one, above and below those ones, you must have zeros. If it's just echelon form, no. Echelon form, you need this one. But you don't assume that everything else must be zero. So this is going to be the difference between these two terms. Okay, so what is going to be the advantage? Advantage is when we want to solve those system of the equation, if it's going to be in leading term, it's very easy to find the solution. You see, nicely we can find the solution right away. So that's why they are important, and there are some other properties of this type of matrices. Now, so what's going to be next? What's going to be the application? The application is, first thing to do is, if a general matrix is given to you, you should be able to reduce it. Okay, change it to this format. We can change it to this format using some, okay, we call it elementary row operations. You see, when you want to solve a system of the equation, remember, if you want to use addition method, so what do? You may multiply one of the equation by a number, or you may divide. Okay, that would be one. So in this case, it's going to be the case that we can multiply, you see, a row by a number, if you like. The other one is sometimes for the elimination method, we add or subtract these rows, or we multiply one of them by 2 and we add it to the other one because we want to eliminate one of those variables. Okay, so those type of operations are going to be used for these matrices. We are going to use those operations in order to convert the given matrix into the row echelon form or reduced echelon form. Okay, so these operations are going to be a standard one. So we are going to introduce those operations, and your job is going to be to apply it. Okay, so what is going to be, we can use these, okay, those operations, and we arrive at the so-called equivalent matrix. So this matrix would behave like the, like the original one, but that will help us to solve to solve those system of the equation. So let's introduce the license, the operations that you can use. So there you are. We are going to call them, this is it. So we call them elementary. Okay, so what's going to be elementary? Okay, what's going to be elementary, say, elementary row operation, row operations. Okay, that's it. So if you like, one can, or one can apply the following. Okay, the following row operations. You can do the similar one with the columns, but we do the row only. Okay, one can apply the following row operations to convert a given matrix, okay, to its row. Okay, this is it, row reduced echelon form, or to the one that's going to be equivalent to it. Okay, it's not going to be equal to, but it would be the same. So the operation that it's going to be all right, and you can use the first one. You can interchange any two rows. Everything would be fine. So sometimes we need it. Okay, row interchange or interchanging. switch the row. Okay, so for example, this is the notation we're going to use. The row I, you switch it to the J, with the J, if you like, or the other way around. Okay, so this is interchange. So this means interchange the, if you like, this means interchange. Okay, this means interchange the i's and the j rows, row vectors, if you like. So that would be fine. We refer to the row interchange and we do it right away. Okay, that's the first one. The second one, we may multiply or divide. We call it row scaling. Row scaling. Row scaling, we have the row I. We may multiply by something like S times Ri, if you like. Okay, so multiplying the I rows by a non-zero scalar. Okay, so this means that's it, multiplying the I rows by a number. I rows vector, if you like, vectors by a number, by a non-zero number. Okay, we call it a scalar. That number can be real, or at the end of this course can be complex numbers. Okay, so this is going to be row scaling. The third one, we may add or subtract the rows. We multiply one of them by 2, we add it to the other one. So row addition. Row addition. So what we do is we have the row Ri. It will be the same if you know, if you get the Ri, but add it to the, S times Rj, if you like. Okay, so this is add to the I vectors, a matrix. So add the I rows to, to S times the J rows. It's clear. So we talk about it when we get to the information. Okay, so we can multiply one of them by 2 and add it to the, add it to the other row, and everything would be the same. These are the operations that we use when you want to solve the system of the equation using elimination method, if you like. This is the one that you did it usually. So you are going to try these operations to reduce the given matrix into the echelon form or row reduced echelon form. And these are going to be your assignment of this section of 1.2. Now, the calculators would do it for you, okay? The different softwares, even though CI 83, 84 would do this type of operation. But for the exams, okay, the quiz, for the test one in particular, you have to show your operation for us, okay? You can check the final answer. You have to check the final answer, but you have to tell us how we can find it really using this type of operation. Okay, when we go on further later, you can use it, but this for the time being we want to practice, so don't miss it on the test. We want you to show us how you did use this type of operation for us. Okay, so don't miss it. This is it. Let's try some example of how we're going to do it. So we give you a couple of them. Everything on quiz 1 would cover this one. Everything you want to do so far, you have to reduce these matrices, okay, to be able to do it. So, I post your practice quiz number 1 and the take-home one, so you see some of them. So you can see them. So reduce, this is going to be the instruction. Would like you to reduce the matrix to row reduce echelon form. Okay, you're just using these operations to take care of it. And it's not going to be a difficult operation. It's quite interesting one, and we do it quite a lot. So let's take the first one, and this is it. We have a 2, 1, 4. Okay, 2, 1, 4. That's a 1, 3, 2, and this is a 3, negative 1, 6. That's it. You want to reduce this one. Okay, you know how to do it. Your first row usually must start with the 1. Then you need another one in the second one, if it's possible. It must be shifted to the right, and then the third one, and everything above that 1 or the leading one must be 0. So this is the way you're going to arrange it. You can use the elementary row operation that we talk about it. You can switch the rows. You can multiply by any number you like or divide, or you can use the row addition one, multiply by something added to the other one. So this is the way we're going to do it, and you show your operations. So the first thing I'm going to do, I'm going to switch these two so that I get the one on the top. Okay, so this is it. I switch these two. So I switch the row 1 and the row 2. That will help me. Okay, I can do some other operation quickly if you like. Or, I just switch this one, it's easier, but you can do a couple of operations at the same time. So the solution is going to be, and this is it. I have to rewrite it. It's a 2, 1, 4, and that's a 1, 3, 2, and this is going to be 3, negative 1, 6. Okay, I quickly switch these two. So that gives you this matrix is going to be 1, 3, 2. I have the 2, 1, 4, and this is going to be 3, negative 1, and 6. You see, I got the 1. So next thing I do is I have to get rid of these 2 and the 3. Okay, so what I do is this is R2. I want to replace this one. So I'm going to get the R2 minus 2R1 because that gives you 0 here. And this is going to be R3. So you want to get rid of this one. So it's going to be R3. And you add the 3R1. Okay, because you want to make this one 0, you need a negative 2. So you take it from here. To make this one 0, you need a, okay, you need, I'm sorry, that's a 3. So it's a negative again. Okay, so you need a negative 3. So this is it. Don't write equal to, okay? It's equivalent. So, you can use this notation if you like. So that's it. So the first one would be unchanged, 1, 3, 2. Now add R2, R2 minus 2R1, so that gives you 0. Okay, 2R1, it's going to be negative 6, so that gives a negative 5. Okay, 2R1, it's going to be negative 4, and the positive 4 would be 0. Over here, R3 minus 3R1, so that gives you 0. Okay, 3R1, 3 times negative 3, negative 9, and negative 10. Okay, negative 10. And over here, it's giving negative 2, negative 6. So that make it into the 0, 0, 2. Okay, so that was an easy one. We get this information quickly. Okay, so there you are. So we take care of the first column. It's a leading 1, 0, 0. We go to the next one. This is a negative 5. You have to have the 1 here. So what you can do is you can divide it. It's R2. You change it into the negative 1/5 of R2. So that will help you quickly to get the, okay, so the result is going to be, we have the 1, 3, 2, so it's going to be 0, 1, 0. And over here, at the same time, oh, it's fine. You can even divide this one too. It's going to be 0, negative 10, and the 0. Okay, there you are. I got the 1. You see 1, 1. So I need to make the top and the bottom 0. Okay, so what I do, this is R1. I'm going to add, this is R1 minus R2. So that gives you 0 here. and you want to make this one into the, okay, this is it, this one into the 0, so that's going to be R3. So we get the R3, what's that? So plus 10 R2, and you'll be almost done. Okay, so R2 minus sorry, R2 minus 3R3, you need a 3 here, sorry. It's a 3R2, okay, because you want to make this one to do 0. And so that give you 1, 3R2, that would be 0. Okay, that would be 2. So now I have the 0, 1, 0. And over here, it's R3 plus 10 R2. So that make it into the 0, 0, 0. Okay, so there you are. You have a nice row reduced echelon form. You get the 1, everything else is 0. You get the 1, 0, 0, and the last row is all 0, 0, 0. So this is going to be in row echelon form, and you're done. Okay, so it's not going to be difficult, and sometimes it takes a little bit more time, okay, to get to the result. So I do one more to see what is going to be not the difficulty really, just sometimes takes a little bit more time to find it. Okay, so let's check another one for this row reduce one. Let's see. Okay, we check this one. Just checking the one that I have, so I have be quickly give you the solutions. Okay, so we go with okay, it's fine. I go with this number 2. Okay, that's it. That's the one. So let's check the number 2. So what is going to be our number 2? So we check the number 2 is the following. So I have the matrix. Okay, so this is it. I have the 1, 1. So this actual 0. I'm sorry. That's it. 0, 2, 0, 2, negative 1, 3. Then I have a negative 1, 1, 2, and 0. Then you have 1, 1, negative 3, and 3. And we have the 1, 5, 5, and 9. Okay, this is the given one, and we want to change it to the row reduced echelon form. Okay, so first thing to do, we need to start with the 1 here. So we have to switch to take one of these up to get those apart. So what I'm going to do, I'm going to switch these two together. So I'm going to change the R1 into, okay, into R3. Okay, you have to start with the 1 over here. You can do the 3 or the 4. I just do with the 2. Okay, so this is going to be the solution. Okay, so this is it. I switch 1 and 3. So I just give me 1, 1, and negative 3, and 3. And the next one is going to be unchanged. Negative 1, 1, 2, 0. Okay, I switch these two, so that gives me 0, 2, negative 1, and 3. Okay, and I have the 1, 5, 1, 5, 5, 9. Okay, so I got the 1. Now I have to change the other into the zeros. Okay, so I have to make this one into the 0. I add these two together. So the R2 would be R2 plus R1. So that would disappear. I got already 0 here, so I have to change this one into the 0. So that's going to be the R4. So I change the R4 into the R4 plus R2. Okay, so I add the first one and the second one that give me 0, then the second one, this is it, -1 and 2. So the resulted matrix is going to be the, okay, is going to be the following. The first one will be unchanged. Okay, that's it. So if you add these two together, that give you 0, 0, 2, -1, and 3. Okay, so we keep the third one as is, 0, 2, -1, okay, and 3. So this is going to be the case. And the R4 and the R2, so that gives us a 0, 6, 7, 7, and 9. So this is it. So we take care of the the first column right away. Okay. So we have the first column. Now we want to take the second one. You see we have the 2 here, so we need a 1. So what we have to do, we try to avoid the fraction as long as we can, or otherwise we have to take care of it. We need a 1, so we divide this one by 2, so R2 would be 1/2 of the R2. So that gives you the 1 that you'll be able to do it. And then this is, both of them are the same, because then you have to change this one into the 0. So this is going to be R3. So the R3 minus R2 make this one into the 0. And then you have to change this one into the 0 so we can use the first one. So the R4 is going to be R4 minus 3R. Okay, minus 3R. Okay, I go with the 3R R2 to make it into the 0. Okay, because as soon as you change this one into the 1, the top and the bottom must be 0. So what's going to be the result? The result is that the first one's going to be unchanged. Okay, so this is the first one. The second one you divide it by 2, so that gives you -1/2 and the 3/2. Okay, then this is going to be R2 minus, okay, R3, everything would be 0, 0, 0, 0, and R4 minus 3, R2, so that gives you 0, 0, 3R3. So that makes this one into the 10. Okay, this is going to be the 10, and this is going to be 0. Okay, so we are getting to where we need to be. Okay, so this would be 0 to take care of, but so we got the 1, everything else must be 0, so you have to take care of the top here. So what you are going to do is you have to change the R1 into the R1 minus R2. Okay, minus R2. So that will help you to get the 0 here. And at the same time, you can change this one. You can divide it by 10 to have a 1 here. Okay, so this is going to be the result. So R1 minus okay, R1 minus R2, so that gives you 1, 0. Okay, it's going to be -3 and plus half, so that gives you -5/2, -5/2, and this would be 3/2. Okay, the second one is going to be unchanged, 0, 1, -1/2, and the 3/2. And this is just 0, 0, 0, 0, and you have the 0, 0, 1, 0. Okay, so we are fine with the second column. And now what you do, you just switch these two because you get lots of zeros here. So we switch the Okay, we switch these two together. Okay, R3 and R4, R3 and the R4. Okay, so that gives us a better idea. So 1, 0, negative. We can do number of these operation at the same time. So it's going to be 0, 1, negative half, the 3 half, and this is 0, 0, 1, 0, and you end up with a 0, 0, 0, 0. Okay, so we are almost there, almost. So what we did, we have the 1, 0, 0, we have the 1, 0, 0, we have the 1, but you have to take care of these two parts. Okay, these two top must be 0. So a little bit more operation to make it 0, and then we are done. Okay, so we can easily use this one to take care of these all together to make it into the 0. Okay, so that is it. So this is R2. Okay, so what we're going to do, we are going to change the R2 into the R2 plus 1/2 of R3. Okay, 1/2 of R3. So that give you 0. Then what else can you do? You have to change this one into the 0, and that would be easy. It's the R1. We change it to the R1 plus, okay, plus 5/2. Okay, plus 5/2 of R3 again. Okay, if you add, those would be 0, and eventually we get your result right away. So if you do it, this is going to be the final answer. We get the 1, 0, 0, 1, 0, 0, 3/2. In the second part, we get the 0, 1, 0. Okay, and the 3/2. And the other one would be unchanged. 0, 0, 1, 0, and the 0, 0, 0, 0. So that would be a matrix in row echelon form. As you can see, we get a 1, 0, 0, 1, 0 on the top and the bottom, and 1, 0 on the top and the bottom. So that give you the row reduced echelon form for your matrices, if you like. Okay, so that would be enough because we can continue, but I wanted to give you a break if you like. So we did the row echelon form. Now we are ready to solve a system of the equation using this type of method. So how are you going to use this type of method? If a system of the equation is given to you, you are going to form the augmented matrix. So you change your augmented matrix into a row echelon form. Okay, reduced echelon form. If we change it to the row echelon form, you should look at this one. Easily we can find the solution of the equations. This is called elimination method. Exactly the method that we did in algebra. If you just change the matrix, augmented matrix into, into the echelon form, row echelon form, and do the job, your method is going to be called Gaussian. It was, introduced or proved by Gaussian method. But if you continue and get your augmented matrix into the row reduced echelon form and solve your equation, you have the Jordan method. So we refer to it as a Gauss-Jordan elimination method. For the test, I just refer to it as a elimination method. So it's up to you. It doesn't matter. You can get your augmented matrix into the echelon form and give us the solution, or you may continue, simplify it further to get the Jordan elimination method. Okay, so both of them are going to be the same. So I post another one for you, the second part of this, and discuss these two elimination method for you. Probably I do it on Thursday, afternoon, because I have a class on Wednesday. Then we'll be able to finish this section. Okay, you can have a look at yourself, but your job is to change it to this row echelon form. Okay, so study this one and be patient. All of them can be done, but using a calculator, but we don't want to do it now. We can, because we have to know this type of operations really and enjoyed it and quickly can be done. Then we check those system of the equation. Okay, so let's call this one 1.2 part 1, just a row echelon form, and then we finish it by give you those system of the equations, and then it would be a number of the problems so far that would be good for our first quiz. Okay, so I post this one as soon as it's available, maybe in an hour time. So any question, email me or just come to my office over and just keep up. So have a good one, and see you at the next next part, which is probably is going to be on Thursday to finish this section. Okay, take care. Bye bye.